why you shouldn't be on a carnivore diet if you want to build muscle, part 2. So in the first part of this video series, I focused on why you shouldn't be on a carnivore diet from the standpoint of glucose in particular, of all the carbohydrates, glucose being the main fuel source in the form of glycogen for your workouts, and how that is detrimental for your workouts, both in the performance standpoint and in the anabolic / catabolic side of the equation. Now, today I want to focus on how glucose impacts cellular pathways. So, first up, the thing that we have to contend with is that glucose is the main driver of insulin. It's glucose that stimulates insulin output in the beta cells of the pancreas, and it's also glucose that elevates the concentration of insulin in inside your body. So this is really important because insulin is a very, very powerful anabolic hormone. And periodically elevating insulin levels is very beneficial for hypertrophy. Insulin upregulates all sorts of growth genes and cellular pathways that signal growth. It downregulates a lot of the catabolic pathways. And so by elevating insulin levels and spiking it really high with glucose, we can create a very, very powerful anabolic ambient. The other thing is that insulin and glucose work in pair. Actually, elevating insulin without the presence of glucose can be actually counterproductive. So you need both. You need insulin and glucose, and both of them together actually create a very powerful anabolic effect. The other thing is that a lot of cellular pathways actually get upregulated, and stimulated by glucose. So in particular, adenosine monophosphate kinase, or AMPK, which is a signaling pathway that senses the energy status of your muscle fibers, glucose actually downregulates AMP kinase, and glycogen levels, the increasing glycogen levels, also downregulate this catabolic pathway. So by having high levels of glucose and / insulin, and also by resynthesizing a lot of glycogen post-workout, you can downregulate these and catabolic pathways like the AMPK. So energy levels inside the cell go up, AMPK gets downregulated, and you no longer have a catabolic environment. Another thing is that AMPK also downregulates or can block the Emptor pathway. And if you know anything about muscle building and hypertrophy, you should have studied enough to learn that the Emptor pathway is very important for hypertrophy. If you don't know about the Emptor pathway, you really have no business talking about muscle building. The Emptor pathway controls for protein synthesis, both in its efficiency and the total amount of protein synthesis that you get at any one time. So, if energy levels are down, glycogen levels are down, AMPK can actually block the Emptor pathway, and thus creating a less anabolic effect. Also, glucose itself signals in the Emptor pathway in combination with insulin through the AKT pathway, the insulin pathway. It upregulates Emptor, and also through the glycolysis pathway, also a lot of enzymes in the glycolysis pathway have a crossover effect where they can stimulate and upregulate the Emptor pathway. Another pathway that highly benefits from insulin and glucose levels being high is the WNT pathway, which is the pathway that frees up beta-catenin. And beta-catenin, when freed up inside the muscle fiber, actually translocates to the nucleus and starts to translate a lot of growth genes. And glucose really drives this pathway. And finally, we get to muscle stem cells. Now, muscle stem cells, and I'll probably need to do a video on this, because muscle stem cells are very, very crucial for you to be as big as you possibly can. Meaning that if you're really going to play this game of building muscle and really driving it to its maximum, your muscle stem cells will probably determine how big you will get, period. And the thing about muscle stem cells is that muscle stem cells absolutely love glucose. It's like heroin to them. High levels of glucose stimulate muscle stem cells activation, proliferation, differentiation, and fusion. So all of the components, the key components for the transition from muscle stem cell to a myoblast to fuse into a myotube, or in this case to the muscle fibers, are upregulated and potentiated by really high glucose levels. And you can't get high enough when it comes to high glucose levels for muscle stem cells. Now, why is this important? Well, because when muscle stem cells do not activate and fuse to the existing muscle fibers, two things happen. One thing is that you get less repair. So muscle stem cells actually repair a lot of damage that you do when you work out. So your potential for injury skyrockets if your muscle stem cells don't effectively activate and do their job, right? Sorry about that. Another thing is that muscle stem cells have been associated and really tightly associated and correlated with the high responders group within a particular, I shouldn't say that way. I should say that when you put different groups within a workout paradigm to build muscle, what happens is you always have high responders and low responders. And the high responders always have great activity from the muscle stem cells. And also, they have an upregulated myonuclear density provided by, you guessed it, the muscle stem cells. So the muscle stem cells in this group, in these individuals, the high responders, are actually capable of donating a lot of nuclei to the existing muscle fiber. And that nuclei density determines your potential for hypertrophy. So the more nuclei you have per muscle fiber, the faster you can grow. And lastly, one thing that I was actually thinking of while I was speaking, maybe that's why I mumbled so much, and I actually forgot, is that glycogen levels actually affect the MRFs, the myogenic regulatory factors. So another thing that we see from the research is that when glycogen levels start to come down, the protein level of the myogenic regulatory factors, which are very important for hypertrophy, they are the one thing that can control how much you grow and how fast you grow. So the protein levels of the MRFs, the myogenic regulatory factors, come down as glycogen comes down. So the more you train, the less glycogen you'll have, because you're not eating any carbohydrates, you're not eating glucose. Your glycogen levels will start to come down, and as that glycogen level comes down, so will your MRFs, the protein level, the protein concentration of the myogenic regulatory factors. And lastly, insulin / glucose actually upregulate the capability of the myogenic regulatory factors to bind to DNA and actually translate a lot of the DNA. So, for the MRFs to actually bind to DNA, you need to have acetylation of the histone tails for the DNA to uncouple the histones and actually be accessed by the translation factors. You need to have acetylation, and you need to have the translocation of the MRFs into the nucleus so they can bind to the DNA. And if those two things happen, then you get a lot of translation of the growth genes. Well, insulin and glucose actually coordinate this event. In terms of the nutritional standpoint, they are the nutrients that actually upregulate acetylation and the binding of the MRFs to the growth genes so that you can translate a lot of those genes and build a lot of muscle. And that's it for now, friends. Remember, a carnivore diet, although it can be a very healthy diet, and certainly a lot of people have had great results from it, it's not a great diet if you want to build muscle. So just stay away from it. If you want to lose fat, maybe you can give it a go, but if you are trying to actively build muscle, just stay clear of a carnivore diet.